Hi, in this lesson we are going to see how to sketch the graph f of x is equal to 2x squared over x squared minus 1. There are 7 steps. First is find domain. Second is find intercept. Third, find symmetry. Fourth, find asymptote. Fifth, find the intervals of increase or decrease. Sixth, local maximum or local minimum. Step number 7, concavity up or concavity down and point of inflection. Okay, we are going to see the 7 steps here. First step, what is domain? What is this domain? This is a rational function. Denominator should not be 0. The denominator is 0, the function is not valid. So this is x is all real number, but denominator should not be 0 means x squared minus 1 not equal to 0 means x squared equal not equal to 1, x is equal to not equal to plus or minus 1. Plus or minus 1. Actually, minus infinity to minus 1, then minus 1 to 1, then 1 to infinity. This is domain. Note it down. Step number 1 we completed. From this what we conclude? In the graph at 1 and minus 1 there is no line. Okay. This point we concluded. Okay, number 1. Number 2, what is find the intercept? Find the intercept is how to find the x-intercept? Put y equal to 0. If this is 0 means equal to 2x squared over x squared minus 1, then x is 0. Okay. To find y-intercept, put x is equal to 0. So 2, 0, 0 minus 1 is 0. So x-intercept and y-intercept both are 0. So we found 2 points. One is domain minus infinity to minus 1, minus 1 to 1, 1 to infinity. Then second is intercept. So it is x is equal to 0 or y equal to x is equal to 0 and y equal to 0. So that line is, that curve is passing, cutting origin. Either it can be like this, or it can be like this, or it can be like this, or it can be like this. Anything. Because with that 2 point we got this much details. Note it down. Third, find the symmetry. Why we have to find the symmetry? Let us see. Find the symmetry. Instead of x, you put minus x wherever, f of minus x. 2 times minus x squared over minus x squared minus 1, 2x squared over x squared minus 1. What will happen? F of minus x is equal to f of x. Same came. So if you find out this one, if f of minus x is equal to f of x, if you got it, your job is reduced. Why? It is symmetry and even symmetry. Even symmetry means if you find, suppose if you find anything above the x-axis in positive x, you can draw the left hand side because it is just rotate about y-axis. Suppose the curve is like this, means the curve here also like this. Okay. Number 1. Okay. So with this 3 point, what we got it? With the domain, intercept and symmetry. What we got it? At minus 1 and 1, there is no, what is called, there won't be any values. Okay. And the curve is passing through the origin. Third is, it is even function. Suppose the curve is like this, means this part automatically like this. Suppose the curve is like this, means this, sorry, suppose the curve is like this, means this part automatically. But it will not at 1, at -1, there is no values. Okay, got it? Next. Until now, note it down. Next is symmetry. Symmetry, what is the rule? When x is approaching infinity, if f of x approaching to L, then it is horizontal. Not, that is, fourth is not symmetry, fourth is asymptote. When x is approaching positive infinity, then f of x approaching L, then y equal to L is horizontal asymptote. For example, 2 infinitive squared by infinitive square minus 1, 2 infinitive square minus 1 is infinitive square only. So 2. So y will approach to 2. So it is horizontal asymptote. Another simple way, if both denominator, both compare the numerator power, highest coefficient of the numerator power, and compare the, for example, 2x squared, here x squared. This is the highest power, 2x squared. Here denominator x squared. 2x squared over x squared. It is, this is another simpler way. This is the, as per the procedure. Okay. So horizontal asymptote we found out. What is vertical asymptote? When vertical asymptote, when x is approaching A from the left or right, f of x is going to the infinitive, then it is vertical asymptote. Here, when x is equal to 1 or minus 1, f of x will go to the infinitive. So vertical asymptote is x is equal to 1, x is equal to minus 1. Got it? So we got horizontal asymptote y equal to 2, vertical asymptote x is equal to 1 and minus 1. Got it? Note it down. Okay, with the 4 details I am doing now. Domain or not, minus 1 plus 1, no. This is the domain. Intercept 0, 0. It is cutting through the origin. Third, symmetry, even function. Fourth is horizontal asymptote y equal to 2, vertical asymptote x is equal to 1, x is equal to minus 1. So you can draw the curve with the 4 available details. Somewhat, because we don't know local maximum minimum, that is step 5. Step 6 is what is called step 5 is intervals, step 6 is local maximum minimum, step 7 is concavity up and down. Now, until now I am doing. Okay, this all we found out. Now, one thing we found out, it is cutting through the origin. So there is a possibility is like this, not possible, y equal to 2 asymptote. So this is the only possible. Okay, concavity we will come. Until now, this is the only possible. Okay. Okay. Remaining area with the available details, we can see it. Mostly like this, because y equal to 2 asymptote, x is equal to 1 minus asymptote. With the details we came across until now, still we will go through. Step number 5, find the intervals. Find the intervals. How to find the intervals? Find the f dash x. Intervals means intervals of increase or decrease means f dash x. How to do differentiate quotient rule? X squared minus 1. X squared minus 1 times, that is, what is the quotient rule? V u dash minus u v dash over v squared, right? V is x squared minus 1 I put. What is u dash? Differentiate 2x squared, 4x minus u. What is v dash? 2x minus 2x minus 1. If you differentiate, it will be 0. So x squared minus 1 whole squared by v squared. So if you x squared minus 4x cubed minus 4x minus 4x cubed divided by x squared minus 1 whole square, cancel. So what is balance? Minus 4x over x squared minus 1 whole cube. This is f dash x. Okay, when f dash x will increase? When f dash x will increase? When f dash x is positive, it is increasing. When this will be positive, minus 4x x squared minus 1 cube x squared minus 1 whole cube whole square, sorry. Okay. This square number always positive. Our one chapter is finished. Second is 4 is always positive. Minus and minus is always negative. Now our rule is x. X, when x is less than 0, f dash x is greater than 0. For example, x is minus 1. What will happen? It will be the minus 4 times minus 1 will be plus 4. F dash x is positive. So it is increasing. So less than 0 means minus infinity to 0, it is increasing. So what we concluded with our previous 4 steps, it is right. What we concluded, minus infinity to 0, it is increasing. It is increasing. Then automatically it is symmetry about the y-axis, 0 to infinity, it will decrease. This automatically will come. We can conclude here also. When x is greater than 0, f dash x is negative. Okay. When x is greater than 0, f dash x is negative. Good. So increasing is minus infinity to 0, decreasing is 0 to infinity. Okay. Sixth is local maximum minimum. Note it down. Sixth is local maximum minimum. Local maximum minimum is f dash x is equal to 0. Minus 4x x squared minus 1 square is 0 means when x is equal to 0, it is local maximum or local minimum. Okay. From the above 5 steps, we can conclude it is local maximum, but we can prove it in another way. When f2 dash x is negative, it is local maximum. Differentiate v. V is x squared minus 1 square. U dash minus 4 minus u minus 4x. V dash 2x squared minus 1 times 2x. X squared minus 1 power 4. Okay. Minus 4. X squared minus 1 square. Minus minus will be plus 4. 4x. 8x squared. 16x squared. Plus 16x squared. X squared minus 1. Over x squared minus 1. 4. Okay, now what is common here? X squared minus 4 x squared minus 1 is common. I am taking minus 4 x squared minus 1. So what will be balance? 1 x squared minus 1 is there. Here what will be there? Minus 4x squared will be there. Okay, I am taking plus 4, okay, minus 4x squared will be there, divided by x squared minus 1 to the power of 4. This will cancel. So what will happen? Minus 4 x squared minus 4x squared is minus 3x squared minus 1 divided by x squared minus 1 whole cube. It will be plus 12x squared plus 4 divided by x squared minus 1 cube. Okay, if you substitute x is equal to 0, what will happen? 12, 0, so it will be 0, 4 by minus 1 cube, it will be negative minus 4. So if it is f2 dash x is negative, it is maximum. I am telling, f dash x is equal to 0 means when x is equal to 0, okay? Minus 4x over x squared minus 1 squared, we are differentiating v u dash v u dash minus u v dash. This 2x, how it comes? I am differentiating this x squared, 2x, divided by v squared. X squared minus 1 squared, if we again differentiate, it will be power 4. Okay, then I am simplifying. Minus 4 I am taking out. I just rearrange everything. Minus minus is plus. Plus 4x, 8x, 16x squared. That I have written. X squared minus 1. So here x squared minus 1 squared. Here x squared minus 1. I am taking x squared minus 4 x squared minus 1 out. So 1 x squared minus 1 I take out. 1 x squared minus 1 is there. Minus 4 x squared is there because I have already taken minus x squared minus 1 out. So x squared minus 4x squared will be minus 3x squared minus 1 minus 4. X squared minus 1, this and this will be cancelled. So 4 will become 3. So x squared minus 1 cube. So minus 4, if you multiply, it is 12x squared plus 4 over x squared minus 1 cube. Okay, then we are substituting x is equal to 0 here. 4 minus 1 cube, it will be 4 minus 4, it is negative. So x is equal to 0 is maximum. We already concluded this one. We already concluded it is x is equal to 0 maximum. Okay. Okay. Almost we concluded everything. Now next is local, next is concavity up, concavity down, and point of inflection. Concavity up, when f2 dash x is positive, 12 x squared plus 4 x squared minus 1 cube. When it is positive, This is always positive. So when x squared minus 1 cube is positive, f2 dash is a concavity up. So what will happen? X squared minus 1 is positive. So x squared is greater than 1. So x is greater than or equal to modulus of 1. When modulus of x is greater than 1, it is positive. When modulus of x, if you reverse it, so concavity up when modulus of x is greater than 1. Concavity down when modulus of x is less than 1. Okay, there is no point of inflection because there is at no place concavity up and down happens because it is a symmetry, vertical asymptote at 1 is there. Okay, now with all these details, I am drawing the graph. Domain at x is equal to 1 and minus 1, there is no domain. Okay, they have given asymptote y equal to 2 and x is equal to 1, x is equal to minus 1. Okay, first data no 1 and minus 1, so asymptote is there, so it is not there. Second is what? It is passing through the origin, x-intercept, y-intercept. Third is symmetry, even symmetry. Fourth asymptote we found. Fifth is intervals of increase. Intervals of increase is minus infinity to 0. So this side, the curve will not be like this. The curve is intervals of increase is like this because it is a positive. And here also minus infinity to 0. Very clear. Curve is, we draw it. Then automatically due to what is called even function, we can do it rotate about y-axis, but at the same time what is called 0 to infinity, it is curve is decreasing. That is also in two theory is supporting. Okay. 7 concavity up and down. Concavity up is like this, concavity down is like this. Concavity up is minus infinity to when modulus of x is greater than 1. This is 1. Here you see this is concavity up. This is concavity up. When modulus of x is less than 1, this is a concavity down. You see, this is a down. Wait. Finally. Big graph. Thank you for my videographer, my daughter Farzana. Thank you for watching. You fully watch it out. I have already given 4 more examples already. This is the 5th example how to sketch the graph. Remaining 5 example I will do it. You please watch the graph. Please put your comments. Some of my friends, students are putting comments, their opinions. You please leave your comments. Your comments are more valuable than YouTube monetization because that only motivates me to do more. Okay, that only. If you are many comments are telling you are the best teacher, you are clearly explained. I got confused like that. Then I can correct myself. Your comments will motivate me to do more. Please leave your comments. See you